Welcome back to the demo on exercise 9. We'll be completing the model building for the 4-bar mechanism and we'll be attaching it to the BIW structures of the automotive passenger car, and we'll be also importing the CAD for the trunklet, and we'll be trying to simulate the automotive trunklet mechanism. So here, this particular link is called the follower, the second link is called as the coupler, and the third link here is called as the input link. Okay, so we'll finish our model building process and then import the CAD and attach this particular 4-bar mechanism to our automotive trunklet. Okay, so let me go back to the graphical user interface. So here you can either reuse your model from the previous exercise, or you can go to File, Open, Model. So let's go to chapter 9 and let me import this particular file. So this is nothing but the file where you had stopped in the previous exercise. So either you can use the same model, or you can import this model which starts at the beginning of basically imports the end model that you've built in chapter 8. Let's continue finishing the 4-bar building the 4-bar mechanism. So you'll have to create 3 new points using the points panel. So let's go and add. So I'll be naming these points as point G, apply. I'm clicking apply because I want this dialog box to remain open because I'll have to create 2 other points. Then point H and then point I. Say OK. So you can see that in the model browser, you will be getting these 3 points. So once you're done with that, go to point G, and in point G, X coordinate, you can give A30. In the Y coordinate, it is 580, and the Z coordinate, it is 1080. For point H, it is going to be 790 in the X direction, 580 in the Y direction, and 1088 in the Z direction. And for the point I, going to be 825 in the X direction, 580 in the Y direction, and in the Z direction 1009. So we've given the coordinate values for the X, Y, and Z for these points, point G, point H, and point I we just created. Okay, but you're not able to see anything on the screen. That's because you need to fit the screen. So just click on your graphical user interface and press F on your keyboard, and you can see the points that you've created. So these are the points that you've created. Now go back to the graphics icon on your toolbar, and then you need to create a new cylinder that are fixed on the body 1 from E to G, and then from G to H, and then from the point H to I with a radius of 2. Okay, so let's get started. So let's first create 3 cylinders and then we'll give its connectivity. So cylinder, let be default like this, say apply, apply, and OK. So you got 3 cylinders here. So this cylinder, I want it to be between, they all need to be fixed, okay, on the body 1 from E to G. So parent body will be body 1, and then it will be from point E to point G, but its radius should be 2 mm. So you have that now. Next, let's go to cylinder 1, go to connectivity tab. Its parent body is again the body 1, and it is going to be connected from point G to point H. So that's this. So go to properties and change the radius to 2 mm. And if you're getting confused between which body it is, the parent body of this particular graphic, then I've defined it as body 1. So just click on body 1, it will show you. So this particular body, so all these graphics will be associated with this body. Okay, that's body 1. Okay, now let's go to the last cylinder, give its connectivity. So the parent body for this will also be body 1, and then the origin will be from point H to point I. So you have that, and you can go to properties and change the radius to. So now we have all the cylinders or the graphics that are connected. Okay, so it should appear, your model should appear somewhat like this. So now what you've got to do is you need to move the center of mass of this body, which is body 1, from point 4 to point G. So let's go to body 1. So when you click on the model browser on body 1, it brings up the panel of this body. So you need to shift the center of mass of body 1 from point 4, which is currently this particular point is at point 4. You need to shift it from that location to a new location, point G. So let's go to center of mass, and in origin you can go to the point. You can just double tap on this point option, and from instead of point 4 you need to select point G and say OK. So you can see that the center of mass has shifted here. Maybe now let's go back, and in order to visualize this, let's make it transparent. So this is the graphics window here. Let's select this cylinder 0, cylinder 1, and then try making it transparent. So this option to make it transparent. So just for you guys to see how the body's center of mass has moved from this point 4 location to point G. I hope now you can all see it, right? Because I made it all transparent. So I prefer keeping the model like this because I know what's happening in the interior of the model. Okay, so now let's do this. Let's go back to the torque. So I'll minimize this. So that should be in under forces. This by stop torque that we've created, you need to deactivate it. So it's already grayed out, which means it's already deactivated. So you can see that it's already activated. So you can just activate it. So instead of activating it, you need to deactivate. Okay, so you need to deactivate the by stop torque. Okay, and right click on the driving torque also, which is this torque that you've applied, and also deactivate that. So basically you'll be deactivating both the by stop torque as well as the driving torque. And now you need to specify the motion for the mechanism. Okay, so the motion for the mechanism that we'll be specifying, it will be in the form of a 2D spline. Okay, so the motion can be either linear, you can give an expression, you can give a curve, or a 3D spline. And we are trying to use the case of a 2D spline and give the motion for this particular mechanism. So from the project browser, you can right click, say add a reference entity, and from that you can go to curve, or you can simply go to this option on your toolbar. Okay, so you just go ahead and add a curve. So leave the names as default and say OK. You move your radio button to the X values here and click on this file option. So in the model files, you'll already have this particular file called as the motion curve. So click that CSV file and say open. Okay, so you can see that it is attaching the particular CSV file that's been created in Excel. So this X, so you have in this, let's go ahead and see what's there in this particular CSV file. It will open up Excel, so that it has two columns. These are the X values and these are the Y values. So if you go back, the X values will be associated with the block 1, column 1. Okay, and the Y values should be associated to block 1 but column 2. So just make these necessary changes so that it knows what to consider as X values and what to consider as Y values. So once you've done that, you can go to show curve option here to preview the curve that you've just imported. Whether it's imported the right X and Y values. To confirm that, to double check on that, you can go to the show curve option and you get this curve. So this curve looks good. Close this. Now what we'll do is we'll select the motion 1 that we had created. Let's go to motion, and we have created a motion 1, nothing but this motion on this particular revolute joint, right? So let's go to its properties. We'll try to assign the curve that we have just imported to this motion. So let's go to properties and then define by, instead of expression, I'm going to select curve, and I will be selecting the curve that I just created. So if you just double tap on the curve option, this is the only curve that's there in the model. So it brings up this option. So select curve 0 and say OK. Okay, so now that's done, and you can leave the rest as it is. So, and then you can just save your model at this point. So file, save as model. So you can call this for power mechanism. So I'm just calling it class and then save. Okay, so you saved this particular model. Now let's start renaming the bodies. Okay, as you had seen in this particular presentation, this link is called as follower, this is called as coupler, and then the input link. Let's try to rename this model by giving meaningful names. So now let's go to the bodies. You can right click on the free body and then click on rename. So, and you can rename it to follower. So this body here is associated with this link, which is nothing but the follower. And then the body 0 can be renamed as coupler, which is nothing but this body. And this entire body whose center of mass is at this location is input. Okay, it's the input link. So let's rename it as. Now, once you've created all this, it's time for you to create outputs. So you can create outputs on bodies, points, joints, and markers. Okay, you can also directly request for the force, bushing, and spring damper entity outputs. So another way to create the outputs will be using mathematical equations. Right. So in this step, you'll be adding a displacement output between the two bodies using the default entities. For this, let's go to project browser. So this is your project browser, and you right click on your model, say add, and go to general MDL entity, and then say output here. Okay, so you'll be creating outputs. So once you do this, you can leave it default. Okay, and so just say okay. So once that's done, you need to create a displacement output between the 2 points on the bodies. Okay, so for body 1, so you can select the input, and for body 2, you can select the ground body. You're trying to measure the displacement of the input body with respect to the ground body. So that's what this means. So okay, the point on body 1 option. So you can select point I, and for the point on body 2, you can select the global origin. So it needs to know from what point will be taken as the reference. And then in this option, you can leave it as both. So next, we can go ahead and add another output. So this was one way of adding the output. The other way is directly clicking on this option on the toolbar, which will allow you to add the output directly. So right click on this. So it's the next output, okay, that you're trying to measure. So in this, say okay, you can accept the defaults and say okay. And this time we'll be trying to input an expression. So we'll be choosing the expression option from the drop down menu. Okay, once that is done, in the F2 field, so this is where we need to go. This is the F2 field. Click on this. This is the expression builder, and we need to build the expression. So you can delete this 0. So these are the codes in between which you need to enter the expression. So that's fine. Now let's, so what expression do you want to use? So I think if you just rewind back and go back to the theory of this class, you'll get to know that I told that we'll be using something called as the dx function in the exercise demo. So that's the function I'm going to use here. Okay, so let's go to the motion tab, click on the dx function. Okay, and from the properties tab, now that's the function name, and now we'll be trying to input the arguments inside this bracket, okay, for this dx function. So let's in the properties tab, go to the bodies, okay, expand bodies, and in bodies go to the ground body and then select its center of mass. You can expand the ground body. In the ground body, center of mass marker, okay, so it is nothing but this marker's string ID or the ID string. Okay, so we need to add that here, so you get this, and then you need to input the ID string of the center of mass of the second body. So this was the ground body, right? Now you need to do that for the second body. So go to put a comma, come out of this parenthesis and put a comma, and then open 2 other parentheses, and in between these 2 parentheses try to do the same thing. So this one you expanded ground body, but this time it will be the input body. Okay, so you can minimize this, go to the input body and then go to its center of mass and then get that ID string. So you added that now. So after doing this, click on OK, go here. So you've got this expression that's you've been added here. So in order to check if there are any errors in your model, you can go to Tools and check model and see what it says in the dialog box. So it says finish checking models and you haven't got any error message. So your model looks good. Say OK and close. And you've got the IDs of the center of mass of the ground body and the input body here. So now it's time to import the BIW models for the car and the trunk lid. So for this, we'll be going to import geometry menu. So you can either go to File, Import, Geometry, or you can just directly use this shortcut on the screen. So here, please follow the steps very carefully. So you need to import geometry. So select the second option because I want to just import the CAD. I don't want to import the mass or the inertia associated with it. So I'm going to select the second option. So once that's done, here I'll be selecting HyperMesh. So I'm going to import an FE file. So I'm going to select HyperMesh, and then in this, the input file, I'm pointing it to trunklet.hm. So .hm is an extension for an HyperMesh file. So it's in this particular working directory. Say open. So it gets loaded in, and the output file I want it to be saved as. You can change it. By default, it takes the same name. You can also change it to say something like mytrunklet.htd. Okay. Say save. So once that's done, just click on this option. You can leave it to allow HyperMesh to mesh it automatically. So you can leave it to 5. If you check this, it will go to 5. But if you uncheck this, it will select its own coarse roughness, coarse mesh size. So for this particular simulation, you can allow it to have coarse mesh size. So you need a fine mesh size only when you come to 3D contact simulation. So then just say OK. So if the import is successful, you need to get a message saying your import is successful. Okay, so you got that. Importing the file succeeded. Okay, so you can close this. So you can see that the automotive trunk lid, which was already created, it got imported here. And the reason I created the hard points here, so you might be wondering why I created these hard points at these specific locations. That's only because I didn't want to change it after I imported this. I didn't want to position this the HM file after I imported it. Instead, I wanted to create this at the right location. So that's the reason why I input these numbers. Okay. So when you're trying to build a model from scratch, then you have to experiment and get the right location of this CAD based on where your input model is. Okay. So once you've got your trunk lid here and there were no importing errors. Okay. So just follow the message log very carefully. Okay. Now let's go to the graphic option here. So you have this. Okay. You need to select this. So if you go to this option on the project, on the project browser, you can go to connectivity tab. And if you go to the connectivity tab, you can see that the model is imported, but it is not connected to anything. It seems connected on the screen, but still in reality, it is not connected to anything. So you need to basically connect it to a particular body. So here in the body, double click on body option and then click on this trunk lid. It should be attached to the input of the 4-bar mechanism. So select this and say OK. So now it gets attached to that. Now let's do the same thing for importing the BIW of the car. Okay. Now I'll be using the shortcut option, which is the to invoke the CAD import utility. I will be importing just the FE model, okay, without importing its mass and inertia properties. So, and then I'm going to open this. I'm going to import this. Okay, this is the BIW of the car. Say open, and maybe you can save this as the HTTP file, my trunk graphic. Okay, so say save. You can leave this to default and say okay. So that got imported and there was no issue while importing. So just follow this message log. So once this is imported, again, you can go to the BIW of the car. You can see that it says it's unresolved, which means it's still not connected to anything. So you got to go to body and connect this to the ground body. The trunk was connected to the input follower. This one, which is the BIW of the car, is connected to the ground body. So once this is done, you can save your, so you try saving your models at every major step, because if something happens, then recovering the file will be a problem. So it's a good practice if you can try saving your model at every step so that you can keep a track of it. So I'll just call this as 4-bar mechanism, so with the trunk lid. Okay, so I'll just save it like this. Okay, now let's go and simulate the model. Come to this run option here. Okay, and the end time you can keep it as 4 seconds, and you can leave the print interval as it is. So here you can save the model as trunk test. So let's just test the model. So I'll just call this as trunk test something, and then go to save. Okay, so once that's done, you can go to the run option. Okay, let's see if there were any error messages. It has run successfully, so you can close this, and then you can go to animate. So this brings up your HyperView. So one more thing that you gotta notice is in Motionview you could see this 4-bar mechanism that you've built, right? If I go back to this, let me fill this to screen. So you can, and let me try to make this transparent so that you can see the 4-bar mechanism. If you zoom in, if you keep zooming in, you can see that the 4-bar mechanism that you created. All right, so that was created only using the primitive geometry. So that's the reason it's not shown in HyperView. Okay, but that does exist. The 4-bar mechanism does exist here. Okay, so let's go back to HyperView, and then you can hit on play. Yes, so now you can see that this trunk lid, it is going beyond this, right? Beyond this particular location. So in reality, it is supposed to stop when this section here meets the BIW of the car, but the way you define it, it's going beneath that. So that's the reason, that's one of the assignment questions that I'll be giving. How can you restrict the motion of this lid to stop exactly when it collides? Okay, that is something using the collision detection algorithm. It's very easy. As I mentioned in my theory class, you can give an option saying in HyperView, stop on collision. So as soon as this lid meets the BIW of the car, there is a collision, and hence the animation stops. So that's just the, for the crude way of doing it, but you can alter many things. You can either play around with the buy stop function or the CSV file that you used to import the motion. So this is basically doing this because of the motion that you get. So you can either play around with that and make this trunk lid stop exactly when it meets the BIW of the car. So let's go back to Motionview. Let's stop the simulation here and go back to motion. So I hope it's all clear. So this basically brings us to the end of module 1. So using all the fundamental knowledge that you've learned so far, you could finally build the automotive trunk lid mechanism. So now let's do one thing just to confirm if we got the right curve imported and if the motion is making sense. What we can try to do is to plot that result, okay? Because we've requested output, so we can try to plot it, okay? So let's go to hypergraph, okay? So you got your hypergraph here. So here you can choose marker displacement, and then you can choose this particular option on the input link, okay? For the component, you can choose DM, which is the magnitude of the displacement. Say apply. So this is your displacement of the input link with respect to the ground body. Okay, so this is how it looks like. So this means that you've done the simulation in the right way. So the maximum displacement is around 1545 units. Okay, so if it's in mm, then it's in mm. So it's like 1545 mm. Now let's go back to Motionview and expand this. So now it's the time to go to HyperView and check how the collision detection algorithm works. So let's try to do that. Let's expand this. So I'll click on this icon. So I think I've already mentioned this in my theory class. If this icon is not already present, then you need to enable this by going to View and then going to Toolbars and then HyperView and then clicking on Tools. So this will bring this icon on the toolbar. Okay. So before going to that, I want to show you one thing. You don't see any mesh right on the screen, but actually it is meshed. So to visualize that, you can go to this particular option, which is the graphics option, and just say all. So it selects the entire thing and click on this. So this is the automatic meshing. It's done, but this is how you visualize it. So usually it will be switched off. It will be, in this particular, so you select everything, say all, this option here. So you can't see the mesh. Okay. So if you want to activate it, in the sense, if you want to visualize it, then you have to go and click this particular option. So now let's go back to collision detection algorithm. I did this because I want you to see the difference when you say in proximity section, when you select elements, what happens, and what happens when you select components. To make it very clear, I've made this particular, I've got this particular visualization for you guys. Okay. So the way how it works is you need to add a collision set. So to this, I'll be selecting this trunklet and adding it to group A, and the entire structure of the car will be added to group B. Okay, once this is done, you can enable proximity and you can say minimum distance can be 1 mm. So once you say this, say apply. Now you can play the animation. So now the radio button is selected to components. So what happens here is this trunklet, as it goes and meets the BIW of the car, you can see that the whole thing turns red. Okay, because the components are selected. Now see what happens. Observe very carefully what happens when I select elements. So go to this particular radio button and say apply. See what's going to happen. So only the elements that come in contact will get highlighted. So I'll try to zoom in so you can see clearly. So only at these locations and these locations, so it gets highlighted. So this is what happens between when you select elements and then components. And one more thing is here in the animation event, you have these options. Okay. If you say ignore, if now by default it is ignore collisions. That means even after the collisions happen, still it is continuing to do the simulation. So see what happens if you select stop on collision. So as soon as it collides, it's going to stop. Okay. It's not going to further do the animation. Now, if you select stop on proximity violation, okay, let me select this and simulate this, and then see what happens if you when you select stop on proximity violation. So as soon as this particular condition here is violated, okay, when the minimum distance becomes more than this, it stops the simulation. So that's the use of this animation event. So I hope now this collision detection algorithm is clear for all of you guys. Okay, if you have any doubts, we can discuss that in the support session. So this brings you to the end of module 1, where the end result was to create an automobile trunklet mechanism by using the 4-bar mechanism that you built so far. So I hope now it's clear to you all by using the basic knowledge that you learned till chapter 9, how you could finally use that and build a pretty, it's basically switching from a beginner level to an intermediate level. So this is where the transition is happening. You used all those tools that you learned so far to come to this point wherein you finally simulated the automotive trunklet mechanism. Let's go back to Motionview. You can enlarge this. You can save this final model. So please save this model because you have, as I mentioned, you have an assignment on this. So I'll be sending that assignment in the form of a presentation shortly. So, and if you have any other doubts, we'll be discussing that in the support session. Thank you.